at the initial velocity. Any questions so far?
No question, sir.
No, huh? No. No, then you read this one. Question
All
5.6.
others given quantities remaining the same, how would the answer change if the initial angle was similar? Why?
Okay, right. All other given quantities remain the same. I don't care about other, the mass and so on. I just want to know the I want to know about this vertical height, right? The vertical height. How would the answer change if the initial angle was smaller? Okay. Now, the vertical height is 1 meter. That means this 1 meter is the same. The vertical height is actually 1 meter. The vertical height is 1 meter. So, okay, 1 meter. The vertical height is 1 meter here. Okay. So the vertical height, oh, sorry, never mind. They say the vertical height is the same. How would the answer change if the initial angle was smaller? Now, if you want to reach this smaller height and the initial angle is smaller, it will be something like this. Now, in the first case, if you want to reach the same height, it will be something like this. Right? Okay, here. This one, angle smaller, angle smaller, angle smaller, same vertical height, same height. Okay. This one, angle bigger. That means the angle at which it is jump, the angle of projection with respect to the horizontal. This one, the angle is bigger, angle bigger, same vertical height, same maximum height, same maximum height. Okay, so imagine you are the grasshopper. You want to make a jump with a small angle and reach this height. Or you are the grasshopper, you want to make a jump, you want to reach this height, but you make a bigger angle here. Okay, so in order to move a greater horizontal distance here, a greater horizontal distance here, you need more energy. Whereas if you jump at a bigger angle and you will reach the maximum height within a shorter distance, you need less initial kinetic energy, right? Okay, so let me continue over here. The initial velocity has to be higher. That means this one, this case, with a smaller angle, the initial energy, kinetic energy, the initial velocity has to be higher. Okay, because you have to go through a longer horizontal distance to reach the vertical height. This one, the initial velocity is, it doesn't need so much initial velocity because you are going to move through a smaller distance, a shorter distance before reaching the maximum height. Okay, before reaching the maximum height. So you need to have a smaller velocity. Okay, so next one. The vertical component of the velocity is relatively smaller to the horizontal component. In order to achieve the same height, the initial velocity has to increase. Okay, the vertical component of the velocity is relatively smaller to the horizontal component. Right? So because you want to move through a bigger distance, a smaller angle here, so this vertical component is relatively smaller than the horizontal component. Right? That is what we mean. So in order to achieve the same height, in order to achieve the same height, you need to increase the initial velocity. Okay. Any questions so far?
No question, sir.
No question. Okay. Now, we're going to make use of this same equation. Let me clear the drawing, clear all the things first. So either this example 5.6 and this exercise 5.6, they make use of the same concept. Right. Remember, you read this 5.6 first.
A catapult launches a rock at 30-degree angle with respect to horizontal. Find the maximum height attained if the speed of the rock at its highest point is 30 meters per second.
Okay. The catapult launches a rock at an angle. Type in this thing. At an angle. At 30 degrees angle with the respective horizontal. With respect to the horizontal. Find the maximum height attained if the speed of the rock at its highest point is 30 meters. Now, what they mean by this? What they mean by this? The speed of the rock at its highest point is 30 meters per second. Okay. The speed of the rock at its highest point is 30 meters per second. Now, you know that at its highest point, there is no more no more vertical component. The vertical component of the velocity has translated into potential energy. So when they say this 30 meter per second, this 30 meter per second is solely the horizontal component of the velocity. Okay, now, so let's say we have an initial situation like this. The initial situation is like this. The initial velocity is at an angle of 30 degrees with the horizontal. So the horizontal component is Vi cos 30. The vertical component is Vi sin 30. This is initially. Finally, when it reaches the maximum height, it becomes like this. There's no more vertical component, there's only the horizontal component. And they say at this time, the speed is 30 meters per second. So they are actually trying to tell us this horizontal component is 30 meters per second. This 30 meters per second. Okay or not? So this 30 meters per second is not referring to the vertical component or the instantaneous velocity at an angle like that. They are referring to this. So Vi cos 30 equals to 30 meters per second. So from here, I can solve for the value of Vi. That is the initial velocity. So initial velocity, you just take 30 divided by this cos 30. So 30 divided by cos 30. Cos 30 is actually 1 over root 3. 1 over root 3. So better right here. Cos 30 degrees. Cos 30 degrees is equals to 1 over, no, it's not 1 over, it's cos 30 is root 3 over 2, sorry, root 3 over 2, root 3 over 2. Root 3 over 2, yes. Okay. Cos 30, the trigonometric ratio, cos 30 is actually root 3 over 2. So I use this root 3 over 2, I substitute inside the cos 30. So the 2 goes to the top, it becomes 60. Right? So this is the reason why I have this 60 over root 3, because the cos 30 is this. Okay, now I can apply the conservation. I have found out the initial velocity. Right? Find the maximum height attained. Okay, so what is the final height? We are going to use the conservation of energy. Where is it? This one. Okay, we are going to make use of this here. Okay, we're going to make use of this here. Okay, okay, we are going to match this. The initial kinetic energy, half mv squared. The initial velocity is vi, so half mvi squared. So the grasshopper, the position is ground level initially, so the mg 0. Finally, when it reaches the maximum height, it has a velocity of half mv squared. Now this v square is half mv squared. This vx is actually 30. The vx is actually 30. Okay, then the maximum height we don't know. We call it y. So this is the potential energy finally, mgh. Initially is 0, finally is mgy, the potential energy. Kinetic energy initially is half mvi squared, finally is half mvx squared. Okay, so substituting the vi with 60 over root 3, we have found out here 60 over root 3, and the horizontal component only is 30, and the y is what we don't know, so we put gy. The mass will cancel off, all the mass will cancel off. So simplifying all this, you will get square of this is 3600. 3600 divided by 2 is 1800. Root 3 square is 3. This one is 900 divided by 2, 450. G is 9.8. So solving this equation, we know the maximum height is 15.3 meters. 15.3 meters. Any questions so far?